Hello, everyone. I'm Ron Brolio. Welcome. I'm professor in the English department and director of the Humanities Institute at Arizona State University. The Humanities Institute supports research and creative engagement in what it means to be human in a constantly changing world. And we're here for the Tomorrow Talks series, which places thought leaders of today in conversation with the change makers of tomorrow, our students. And each distinguished speaker explains how they use humanity's perspectives to address our world's most pressing challenges. Today, we welcome Melanie Mitchell, author of Artificial Intelligence, A Guide for Thinking Humans. Melanie Mitchell is a professor at the Santa Fe Institute, and her work bridges the fields of artificial intelligence, cognitive science, and complex systems. She focuses on the role and mechanisms of abstraction, analogy making, and reasoning in humans and machine intelligence. She's author of a number of books, including today's discussion about artificial intelligence, a guide for thinking humans. Her conversation partner is Kyle Jensen, the Assistant Dean of AI and Emerging Technologies at the College of Liberal Arts and Sciences here at Arizona State University. And he is author, co-author, or co-editor of 6 books and numerous essays. His research on writing instruction, artificial intelligence, and public literacies has received grant support from the National Endowment for the Humanities and has been featured in the Washington Post, The Atlantic, and Times Higher Education. So please join me in welcoming Melanie Mitchell and Kyle Jensen.
Hi, Melanie. How are you?
Doing well. Thanks for
Uh,
inviting me to this, Kyle.
well, I'm so excited to have this hour to talk with you about this book that you've written, Artificial Intelligence, A Guide for Thinking Humans. I don't know if you have if you know that you have a growing fan base in Tempe, Arizona, but anytime someone asks me, what book should I be reading to get up to speed about generative AI, I always hand them a copy of your book because I just think it's so fantastic. It has taught me so much. So I'm thrilled to ask you a series of questions, and I hope that we'll have a great conversation. Does that sound good?
Perfect. Thanks so much.
All right. So the title of your book, which was recently actually just reissued with a new preface, is Artificial Intelligence, A Guide for Thinking Humans. I'm wondering, what are the qualities of someone who adopts a thinking approach to artificial intelligence research? What kinds of questions do they ask, and what kind of behaviors do they engage in?
Yeah, that's a great question. The book title was a little bit of a play on words, obviously, since I think all humans are thinking humans, and it's debatable to what extent we have thinking machines yet.
Yeah.
But I think that, thinking humans, thinking about AI should have the qualities of both sort of wonder and curiosity, and also skepticism and critical thought. And it's challenge to keep those in the right balance. These systems are amazing and impressive, and sometimes they just seem quite magical in what they can do. But we should wonder how they do what they do and try and educate ourselves on that. And also avoid the kind of magical thinking that we've seen in a lot of the media reports. And I think what a lot of people come to AI with a feeling that this can't be explained. So, just one example of that was there was a segment on 60 Minutes, the CBS show, 60 Minutes on AI. And one of the things that they said, it was kind of like almost like a PR release for Google. The president of Google, the CEO of Google said, these machines, our AI somehow learned Bengali without ever being exposed to Bengali at all. Magic. How could that possibly be? Well, of course that's false. Of course there was Bengali in its training data, but a lot of media outlets reported it as this. And I think we've seen a lot of similar hype from the media and from AI companies And so a thinking person has to be skeptical of that hype. And the other thing they have to really question is this narrative we have of inevitability. We have this narrative that AI is taking over everything. It's going to replace a lot of jobs. It's going to be in every product you use, and you have no say in it. Kind of feels that way today when you just see it everywhere and you really don't have a lot of say. But I do think we as humans, as thinking humans, have more agency than perhaps we know in order to be able to shape and control and regulate the role of AI in all of our lives. And that's something that I hope to write about in my next book.
Well, I can't wait to read that next book. I'm so thrilled to hear that you're working on something new. And this idea of agency, I think, is really important. Thank you for bringing that up, in part because so much of generative AI is overwhelming. It's seemingly magical capacities, as you said. It's its ability to have broad functionality in a lot of different domains. And as you said, most people don't really know how it works. So in your book, you describe the amount of human-generated data required to model and train large language models as mind-boggling, and credit the confidence of applications such as ChatGPT to its sourcing of massive data sets. Do you think that the scale of LLM operations is understanding how they work? And if so, how do you help non-experts understand the complexity of the applications they're using? Or is that even really important?
I think it's very important and obviously difficult. These are very complex pieces of technology that have been trained on unimaginable scale of data. Basically every piece of human text that's ever been digitized. And now we have these systems being able to work with images and videos and audio and all kinds of different modalities. So it is very complex, but I think there are principles about how it works that we know. Not everybody. It's not totally clear how everything works in these systems, and they're complicated. But there are a lot of principles that we already know, and that's that they're, for instance, very reliant on the training data. And one thing that I think it doesn't come easily to us is to imagine the scale of the training data. So, the notion of, for instance, the system suddenly being able to speak Bengali. And we have to imagine that almost everything, every language, every book, every piece of data that you can possibly think about has been in the training data of these systems. And the amount to which they rely on training data is enormous. And I think that's something that, that sort of disconnect between our intuition about how much data there is out there and the reality is really important to really try and get a grasp on. So I think there needs to be some more sort of public friendly explanation or metaphors that help us understand that notion of scale.
I totally agree. Do you want to ballpark just how many texts a large language model has to incorporate in order to be modestly accurate?
Uh, I should have prepared for that, but
I'm sorry.
but you can think of all of the books that have been written and digitized. Uh, that's an enormous amount of text. Well, okay, here's one kind of numerical value that I know. If you count how many words a 10-year-old child has been exposed to during their lifetime, and that's, just counting every single word, whether it's repeated or not, that child has been exposed to, that's on the order of 5,000 times less than what ChatGPT has been trained on.
Wow,
So
that's amazing.
it's orders of magnitude. Yeah.
That's amazing. So in Artificial Intelligence, A Guide for Thinking Humans, you spend a good amount of time telling the history of artificial intelligence research from the 1950s forward until now. And I'm wondering, why is it important for everyday users of generative AI applications to know something about that history? Is there an episode that is one of your favorite episodes in the history of artificial intelligence where you're like, ooh, if that would have bloomed, that could have been a really important moment for us? Or is there a favorite episode where you think more people should know about this?
Yeah, I think that just as a matter of general knowledge, it's good to know something about the intellectual history of our culture, and AI is one big aspect of that. Uh, for the practitioners in AI, I think it's even more important, although maybe not that common nowadays, to understand sort of what's come before and what we're sort of repeating in some ways and what's genuinely new. I think very few students get any kind of, even in computer science, get any training in the history of these fields. And so they think everything is brand new as of like 5 years ago or something. And it's just obviously not the case. But one important thing that I think comes out of studying the history of AI is really a clear sort of evolution of our understanding of what intelligence means. So back in the 1970s, people thought that if we could get a machine to play chess at a grandmaster level, that would necessarily encapsulate all of human intelligence, because chess is at the pinnacle
Right.
of intellectual activities. People, a lot of very, very prominent people said that. And then we got a machine to play chess at a grandmaster level in the 90s with Deep Blue beating Garry Kasparov, but it didn't accomplish general AI. All it could do was play chess. It couldn't play anything else or do anything else. And that was, people were surprised, people were shocked, but it wasn't really what we had meant by intelligence. So, the same thing has happened again and again. And I think most recently, even with generating fluent language, that has been always associated strongly with intelligence. And yet we see machines that can generate fluent language and seem really smart, but lack fundamental aspects of intelligence when you start to probe them. So history is important for that reason. And you asked that, what episode kind of got missed.
Yeah.
So, neural networks were sort of a forgotten technology until they were rediscovered, or people really started scaling up the compute needed to run them. They were inspired by the brain. There's another AI technology that was inspired by biological evolution called evolutionary computation or genetic algorithms that has kind of fallen by the wayside. But more recently, people have started scaling it up the same way they've scaled up neural nets, and finding that it actually is incredibly promising for developing certain kinds of intelligent behavior. And I think that's something that we'll see more and more. So this notion of having a lot of data and a lot of computing power can really breathe new life into a lot of quite old technologies. And you may not know that deep neural networks and language models, for that matter, were around as far back as the 1950s, but they never really worked well enough until we had the enough data to train them and enough computing power to run them.
Well, now you've just piqued my curiosity, so I'm going to ask a follow-up question. Tell me more about evolutionary computation. What does it do that is unique relative to the way that neural networks function, and how do we learn more about it? Why should we be excited about it?
Well, neural networks, a kind of model learning like the kind that you do during your lifetime. You learn to differentiate cats from dogs. You learn about, say, if you're a driver, you learn about stop signs and traffic lights and pedestrians and all of that. And neural networks are pretty good at learning a lot of those things. But one thing they're not good at is fundamentally changing their own structure.
Mm.
And evolution is kind of a paradigm for this change of structure in organisms and allowing organisms to adapt to a changing environment. So that's something that evolutionary computation has always tried to capture, and that traditional AI or traditional machine learning has never been good at, is this sort of continual change and adaptation over very dynamic environments. And so I think that's something that evolutionary computation is going to contribute to in terms of this whole AI ecosystem.
So who is the person, or who are the scientists that are doing really good work in that area? Basically, I'm asking you for a book recommendation, and I'm asking
Oh,
on behalf
wow.
of the audience, who should we be reading to learn more about this?
Oh boy, that's a great question too. Yeah, I don't know if there's a lot of good um, description of this for kind of the general public.
Mhm.
Um, there's a number of people, both in academia and in industry, who are working on sort of these evolutionary ideas. There's a whole field called artificial life, which is like artificial intelligence, except it tries to recreate life in digital forms. And there's some spin-off companies that are startups that are really kind of buying into that idea that we should be trying to not just recreate intelligence in the form of problem solving, but we should try and recreate something more lifelike and
Mhm.
adaptive and able to adapt to different environments.
Okay.
So I don't know if I have a good book recommendation off the top of my head, but I'll think about it and maybe,
We're all good researchers. We'll
yeah.
figure it out. Well, it's interesting that, you ended the answer to that last question about the development of artificial life, and I think there's reasonable concern, or maybe it's just media hype, and you'd have to weigh in on this and help me understand better about AI creating a certain amount of existential threat to human intelligence, or just to human biology in general. Um, and my next question has to do with regulation and the role that regulation should play in AI development. So, in your book, you argue that regulation shouldn't be left solely to the hands of AI researchers and companies, because the problems surrounding AI, trustworthiness, explainability bias, vulnerability to attack, and morality of use, are social and political issues as much as they are technical ones. And for this reason, you recommend that discussions around AI involve people with different perspectives and backgrounds. So I told you when we were talking before this talk, this event, that I study rhetoric, and so I know, and I'm sure you know, that granting a hearing can be really challenging. Granting a hearing to different perspectives can be really challenging, especially when there's a significant amount of capital at stake. So I'm wondering if you can talk a little bit about how researchers from different backgrounds who have different motivational frameworks can learn to hear one another, so that we can pursue a dimensional understanding of AI as a social and political issue.
Wow. Yeah, I mean, that's always been hard to have people from different perspectives hear each other. Always a big challenge. I think in AI, there's a lot of groups that are trying to make that happen. It used to be the case, at least in big tech companies, that they would have ethics groups where they would have people from different perspectives, not computer scientists or machine learning engineers or whatever. They would have people from philosophy, from the humanities, and weigh in because they have the background think about these issues a little more broadly. A lot of times, unfortunately, those ethics groups are the first ones to get cut when downsizing happens. But I think it's still very important to have these different perspectives. I mean, I was really struck by the video that you had at the beginning,
Right.
kind of an advertisement for studying the humanities.
Yeah.
And one of the arguments for that was, you can think about the ethics of technologies.
Right.
And the humanities gives a very different background than computer science, which is what I studied.
Yeah.
And I think that, as the video said, the humanities explores the human condition, which is important but a little bit lacking perspective in big tech. Technology is supposed to be for humans. So in order to really make it beneficial and useful and not exploitative, it needs people who really understand what humans are and what what these different terms might mean in that context. So I think it is hard, and I don't know how to uh, make it happen. But I think we've been a little bit too focused on sort of technical solutions to problems that are inherently human and social rather than technological. And I think that's one of the reasons why we have so many problems with AI today.
I don't know if you can feel it, but I know my colleague Ron Brolio's, who introduced this, heart is quite literally swelling at what you said, and I know all of my humanities colleagues who are in this event take a lot of courage from what you're saying, because I think it's true that in the domain of computer science, especially in technological development, humanists have quite a lot to contribute to the conversation and actively want to participate. Um, for example, one of my advisees who you'll meet in during the Q&A session has been totally impressed with your focus on analogies and metaphors, and she's going to ask you a little bit more about that. But you have a humanities sensibility to you, whether you claim it or not. So I really appreciate that. Why do you think it is that um, there is a kind of I don't think it's probably fair to say a preoccupation with technical development at the expense of humanists or humanities concerns, but is it just that the computer science is so complicated and the problems are so, nuanced and complex that that's where you have to allocate all of your energy, and that, it's harder to kind of pan out a little bit and think about the social implications of those developments? Is it a training issue? What do you think the source of the problem is?
I do think it's a training issue. I mean, the people who major in computer science or engineering, I mean, I guess it depends what kind of place what kind of university you attend, but typically their education is wholly different from people who major in the humanities. And it's just like night and day. And I think that there is a feeling among engineers and computer scientists that they have been trained to solve problems. And here we have a problem. Maybe it's like bias in AI. Well, they've been trained to solve it, so let's just figure out how to engineer the solution to it. And that's kind of the attitude that can be done. And I think there's been a lot of approaches, sort of techno-solutionist approaches to the big problems of AI. People really do believe that this is the way to solve it. And it doesn't really occur to them that there's something valuable from other disciplines, that other disciplines have actually contributions to make to solving such things.
So I think we've worked our way into a solution in that case. The first step to hearing diverse perspectives is to take courses in fields that maybe don't typically get a lot of run in a traditional educational track, and to try and hear those differences a little bit more effectively, learn the basic terms, not with the goal of necessarily becoming a professional at it, but knowing that the kinds of issues that we care about and tackle are by definition multidisciplinary in nature. Would you agree with that?
Yeah, totally. I think that's absolutely important. One of the big buzzwords in AI these days is alignment. And the idea of alignment is that, well, we can train machines to do lots of things, but it's really hard to train them to always do what we want, to understand what we want, and to quote unquote align them to our values. Okay, so how do we get machines to like do the right thing, the thing that a good human would do? Okay, so that touches on things like moral philosophy and sort of ethics and all kinds of humanistic traditions that most computer scientists aren't trained in. And I have to say that some companies, like, for instance, DeepMind, uh, has hired actually a lot of philosophers to grapple with these things. And they've written some terrific papers. But I think it's, people who understand the nuances of things like what a value is and what ethical might mean and how context dependent these things all are. These are people who need to be listened to when talking about aligning machines with humans.
Absolutely. So you mentioned in your book that we tend to focus on the dangers of AI, and I think that's probably the media preoccupation currently. I can't go a day without signing into YouTube and I see another, series of existential videos like you're going to die tomorrow and these things are going to take over, or conversely, these things are not as smart as we think they are. But you make the case that sometimes we focus on the dangers at the expense of some of the benefits associated with artificial intelligence technologies. So, what are some of the AI innovations that you find particularly valuable, and where should we look to find good news about generative AI that's not overly sanguine or naive, that has that kind of skepticism that you described, but still is forward thinking about the potential benefits of incorporating these technologies into our day-to-day lives?
Yeah, so AI, like any technology, it obviously has many possible harms, but it also has a lot of potential benefits, some of which we're already seeing. I think one of the big areas is science itself. Science um, deals with data, huge amounts of data, often very difficult for humans to make sense of.
Mhm.
And generative AI systems are quite good in many cases at finding interesting patterns in data. Uh, we saw that, for instance, DeepMind's program AlphaFold was able to find patterns in protein data that allowed it to predict protein structure much better than had been done before by other technologies. And that's like a huge boon for research in medicine, in biology, in curing disease, and all kinds of applications for protein folding prediction. Uh, AI systems have gotten better than other technologies at like weather prediction by using a big data approach. And that's obviously another really essential part of applied science that we all really depend on.
Right.
There's been a lot of exciting developments in AI related to science and to medicine that have the potential or already are being very beneficial. It's the there's obviously other benefits of AI systems. Maybe everybody in this audience has used a generative AI system like ChatGPT or Claude or Gemini to do some task that was boring or took a lot of time or actually helped them in their daily life in some way. So there's quite a few benefits. It's just that the technology is a double-edged sword, which has been shown to do do harm as well as help humans. So we have to figure out how to balance that, just like other technologies.
I totally agree. I totally agree. So I think for many people, the persistence of bias in AI output is a deal breaker. Just like talking about like incorporating generative AI into everyday tasks, especially we both work at universities, and to try and incorporate that into the classroom feels like a risky proposition. You note that several groups are working on algorithms that debias word vectors, but suggest that the larger problem is pursuing the other more difficult problem of debiasing language and society. So, to your point earlier, a lot of what comes in the output is a function of the databases that we're relying on to train the models themselves. So how do you respond to critics who argue that the widespread growth and growing interest in generative AI applications makes that difficult problem of bias, language bias, even more difficult?
Well, it's not surprising that these AI systems are biased because they are trained on human-generated data, and humans are biased, and human culture has been biased forever. Uh, and these systems adopt these biases, but one of the problems is that because of their scale, they can magnify such biases. So like a perfect example of that, this is facial recognition software, which works pretty well, but it seems to have problems with people whose skin is darker. Um, and it also has problems like it's better at recognizing male than female faces, young than old faces, other kinds of, skews in terms of its abilities. And we've seen like false arrests and people getting stopped, and police departments misusing these technologies. So how do you fix that? Well, you can help mitigate the problems by fixing the data, by making the data more representative. But since these are pretty complex systems, we already talked about how complex these neural networks are. Sometimes making the data more, well, I'll say less biased makes the system less accurate because those biases might have actually reflected something in the real world. Uh, so there's all kinds of trade-offs. I guess the question is, and again, this is maybe a more humanist than technological question, is when is it right to use these technologies? When is it ethical? When is it fair? When is it beneficial? And these are all human judgments rather than technical judgments. So I don't, I think we don't want to completely throw out the baby with the bathwater, I guess, we don't want to have the fact that there are harms in this technology make people want to completely ban all applications of it. That would, I think, be even more harmful. But we do have to be aware of the harms and understand, the extent to which technology can fix it and the extent to which it can't, and needs something more like uh, legal frameworks and uh, uh, some kind of, very strong oversight.
Okay, so I hear you. What I hear you saying is we just need more humanists in the conversation. I'm going to move on to the next question before you can argue with me on that. Can you tell me more about maybe some of the open questions or problems or limits or barriers that prevent generative AI technologies from advancing further? And who, in your view, are the researchers, other than yourself, who are working on these problems in really thoughtful ways? And what do you admire about the way that they're tackling those problems?
Yeah, that's a pretty big question. Yeah, there's so many things that I think are missing from these systems. One is what I would call metacognition. We have machines that think, but we don't have machines that can think about their own thinking.
Right.
So we humans, unconsciously use ability called metacognition all the time. I realize if I say something, I have some sense about how much I believe it, or how confident I am in it, or the extent to which I'm willing to argue that it's true. For something like ChatGPT, everything it says with utmost confidence, as you probably noticed, whether it's right or wrong. And it doesn't have any good internal sense of its own sort of reliability. And this is one of the reasons we get some things that people call hallucinations, and various errors that are stated extremely confidently. And it's the reason why it never says, "I don't know," because it doesn't know how to say, "I don't know." It doesn't know when it doesn't know. So this is a big issue I think it's been a big issue in AI for a very long time. I'll just mention one other issue, which is the ability to learn continually over one's lifetime. And we know that these systems like ChatGPT are trained vast amounts of data. They're trained for maybe weeks or months at huge cost, but then they're frozen. They don't learn as they go along, and this is very limiting for these systems. And so the idea of continual learning is a very important one. Now, who do I think is doing great work in this area? Well, one of the things that's really inspiring to me now is how many people in cognitive science are getting interested in AI and thinking about how insights from biological intelligence are relevant. We don't, we have aspects of our intelligence that come from these metacognitive abilities, this continual learning abilities, and also due to the fact that we're embedded in the world, that we have access to the world in a way that these systems don't. If I want to see if, for instance, my phone works, I can pick it up and turn it on. Or if I want to see what water tastes like, I can drink it. All these things that are something that current AI systems can't do because they don't have bodies, they aren't actively engaged in the world, and they're instead passively trained on data that we give them. So I think there's a lot of interesting work in cognitive science on trying to think about how you would make AI systems more human-like in these ways, and therefore more robust, better able to generalize, better able to sort of assess their own confidence.
I wanted to underscore a point that you made just a moment ago, that LLMs can't think about their thinking and they have a hard time evolving. They can't evolve based on the kind of feedback they give them, in part because I think when I talk with people about AI, that's their concern, that they're feeding it data and that it's learning from it and then it's adapting in response. But from what you're saying, that's not exactly what's happening. And when LLMs use rhetorical strategies like, oh, if I were to say, no, that's not correct. Oh, you're right. Now that I think about it again, it's giving this kind of sense that thinking is taking place, but that's not actually what's occurring. It's producing something altogether different, or it's structuring perception rather than reflecting reality. Did I hear you correctly on that?
Well, what I meant was, the way these systems work is that they're trained. They have a training period where they're trained on lots and lots of data. Then they're kind of set loose on the world, and what they have is a very big kind of memory for what you're saying. So if in a single session with a chat bot, everything you type and everything it responds is part of its what's called the context window, which is almost like a little working memory where it can refer to, so if like back 10 minutes ago in the conversation you said something about your sister, it can then use that 10 minutes later and refer back to that. But once you've turned it off, once you said, okay, goodbye, I'm getting out of here and ending the session, unless there's some sort of special persistent storage of that context window, which I think is something that these systems can do if you opt in for it, they don't actually learn anything from that interaction in the way that they learn during their training data.
Mm-hmm.
So it's a very different kind of sort of use of information than what we have. And when they, when you say, oh no, that's wrong, and they say, oh, I'm so sorry, they've been in some sense trained to respond in this more sycophantic way. So even if you tell them they're wrong when they're right, they will often say, I'm very sorry, you're right. I realize that's wrong. And they will, always agree with everything that you say.
Okay, maybe they know humans better than we think they do.
Well, they've been trained by humans,
That's
and
exactly
that's
right.
how they get their sort of sycophantic attitude.
So there's a massive environmental cost to AI development and use. Are you concerned about those costs, and how do you talk with colleagues who believe that the benefits of AI do not outweigh the environmental costs of developing and using them?
Well, yes, I do worry. I think one problem is we don't totally know what the environmental costs are. Big companies are not very transparent about that. And it's hard to know precisely how much electricity they use, how much water they use, uh, what the cost is of these big data centers versus, say, a bunch of people driving on the highway or flying in a plane. And I don't think it's there. There have been some studies, but there's a lot of controversy about exactly what these costs are. So I think there has to be a lot more transparency required from companies. I read one article that says, oh, these systems, every time you ask ChatGPT a question, it's like pouring out a glass of water into the sink. And other articles say that's a myth. They don't use that much water at all. And, I don't know. I'm not an expert in this. I don't know who to believe exactly. So I don't know what the costs are compared to other kinds of human activities, but obviously they're not trivial. And building big data centers has other kinds of causes other kinds of environmental problems in the locations where they are, just due to the construction and the kinds of operations that they have. And I know that, some of the big tech companies have proposed vastly expanding the electrical grid or harnessing nuclear power plants to get their systems to improve. And that just seems like the whole enterprise is wrong-headed, because we know that if, anybody who has a 4-year-old child doesn't have to get a nuclear power plant to run that child. They don't take that many calories, right? To do what they do. And what they do is sometimes more advanced than what some of these AI systems can do. So there are other ways to train these systems than the way that we're doing it now. And I think that, those kinds of things they'll become more and more efficient, and we'll sort of figure out how to better train these systems, perhaps by looking at how children learn um, in a way that won't use so much energy resources.
So speaking of kids and learning, why many students, whether they're, I have 3 daughters who are in elementary and middle school and, work with massive student population at ASU. And I think many of them are asking a fundamental question, Why should I invest in my education if AI has the capacity to produce knowledge and prose quality that exceeds my own current abilities? If a student were to ask you that question, how would you answer them?
Well, how, first of all, I don't know if its abilities exceed this student's abilities. Maybe in certain ways, maybe it's more grammatical, but maybe less creative. It's hard to say, but it's a big problem because like, how do we get people who to become experts if we don't train them? And that's in writing, in computer coding, in medicine, in every single field. At some point, the AI system is going to be better than you are because, if you're a beginner and you don't have a lot of experience, that it's obviously going to be better than you, say, at writing computer code. But then how do we get the senior computer coders who actually are needed to make these systems work without having them go through educational processes? So it's kind of a conundrum. And I think that if we just kind of decided that we would leave um, all that kind of tasks to AI, our whole society would collapse. Now there's some hype going on here. So one example is one of the most famous AI people, Geoffrey Hinton, back in 2016, he predicted that, and by the way, he just won the Nobel Prize for his work in AI, which is interesting. He predicted that in 5 years from 2016, that is 2021, we wouldn't need human radiologists. And so students should no longer study radiology. That was what his advice. But now here we are in 2025, uh, and there's a shortage of radiologists. Medical schools can't train enough radiologists. And I think one of the things that he got wrong was like what it is that a radiologist actually does.
Right.
His view was, okay, these AI systems, they can look at medical images and they can classify benign, malignant, or whatever, often better than humans. And he thought that was all that radiologists do.
Right.
But it's not. It's much bigger and richer job than just that. And I think that's going to be true of all human jobs, or at least most of them, that the job is more than just what people think it is and assume that the AI could take over. So I don't think AI is going to take over that many jobs. And if it does, we're in real trouble because for many reasons. But one of them is that then people won't be trained for the jobs that humans still need to fulfill.
Well, I love that answer because we're ending up where we started, which is we need to have a much more expansive definition of what counts as human intelligence. And one way to understand human intelligence is through these really, fascinating, complicated systems, but that shouldn't discourage us from looking elsewhere and other aspects of human experience that are far more dimensional, but maybe not getting as much attention. Would you say that that's fair?
Absolutely. Yes. I think people tend to, a lot of people say, oh, people overestimate human intelligence. I actually think they underestimate it. And
Yeah.
I still think that.
Well, I've asked all of my questions, and I know that there are some of my colleagues and students at ASU that would love to ask a question of you. So I'm going to promote Jonathan McMichael to the screen now, and he's going to ask you a question.
Yeah.
Jonathan, if you're on, go ahead and turn on your video.
Yes. Melanie, this is incredible. And I work as a learning solution specialist at ASU, and I think about the learning part. So this is following up kind of what Kyle was talking about. I think what got to me that really stuck out with me in the book is the barriers of meaning. This idea that we can perform the patterns of learning or whatever the output might be, but getting to that meaning and understanding is seemingly because of this metacognition and continual learning, something that seemingly is a part of human intelligence. if I'm talking with faculty and educators, the distinguishing between understanding and performance is a thing that we're thinking about a lot with the assignments, rethinking what our assignments need to be. How do we distinguish human intelligence versus artificial intelligence? If I can go to AI and just turn in the output as my assignment, and it might meet the rubric or criteria that faculty are giving them. But as a learning solution specialist, one of the things I'm thinking about is exactly what you talked about, is the process that gets you to that learning. The other thing that when you do that, you are supplementing that process that a student has to go through to discover what that means. And if you see the answer at the end, you haven't gone through the making of meaning and the making of understanding yourself. So I guess what I'm asking is, what are some of the ways that we might offer advice to people as we're rethinking what we should do with our assignments? How much can we keep and how much do we need to change? And how much should we kind of think about distinguishing AI versus human intelligence, thinking that maybe even some of this metacognition and continual research might change if they continue research continues to develop on that. And how do we gear it towards kind of the idea that we assign things out not to distinguish intelligence, but to inspire intelligence and learning within people? How do you think about that, but from your perspective with artificial intelligence, and then maybe working within a university, our role?
Yeah, that's such a hard question. I mean, I think everybody in education is struggling with that question, and I don't know what the solution is. There's many different possible solutions. One is that you just outlaw use of AI, and some people are doing that, and they are, I think that they're going to a model that's more like what I think of as the British system, where yeah, you assign homework, but you don't grade it. Students can do it or not. And everything depends on the final exam, which you write in a blue book without any, in a Faraday cage or something. And you, that's one way to do that. And then you're sort of forcing the student to make their own decision about whether they will go through the process of learning in order to pass the class.
I'll ask one quick follow-up because I really liked what you talked about with metacognition, and that's a thing that AI doesn't seem to have. Do you think leaning into that within students to say you should be aware of the learning that is going on within you, giving people language and insight to say this is what learning feels like or looks like from you, and if you can identify that you are learning, that is going to guide you towards something that's there, because that is an ability that human beings have, but maybe not something we've emphasized as much because there hasn't been the option to think about shortcutting that metacognition for our own learning, not being aware that we are learners in that way. Do you think that's something that we should spend more time in classrooms talking about?
Yeah, it seems more reasonable to me. This, you might call it meta learning or something, where the students aren't just robots being fed stuff and regurgitating it for their exams or their homework. I mean, they should be aware of why they're learning, what learning is, and how to know if they're learning. So yeah, I think it's certainly not something I ever encountered in my education, but perhaps it's something that we have to think about more for today's students.
Thank you very much.
Thanks, Jonathan. Okay, Melanie, now we have a graduate student in our English department, Kylie Franzak, who would like to ask you a question about metaphors.
Hello. Yes, I'm a third year doctoral student. This is very exciting for me because I actually just finished a paper that was influenced by some of the things that you had written about. So I'm curious, you've studied computer science and abstraction and analogy making in both humans and AI, and in Artificial Intelligence, A Guide for Thinking Humans. You have a small section at the very end of your book where you talk about metaphors, and you reference Lakoff and Johnson. You talk about how powerful metaphors can be in conceptualizing abstract ideas like AI. And then you just recently published an article in Science where you returned back to this idea, have extended it a little bit, and you've observed how different fields employ metaphors like the LLM as mind to make sense of AI and write. We need to be acutely aware of the often unconscious metaphors that shape our evolving understanding of the nature of their intelligence. So I'm curious what first drew you to explore this connection between the way that we think about AI, the language that we use about it, and human attitudes or behaviors about it. And then also, are there any metaphors that you've encountered or you find particularly useful or accurate for helping us think about AI today?
Yeah, so where did I first think about this? I guess when I first started as a graduate student studying AI, I was even back then, like the late 1980s, I was struck by the very anthropomorphic metaphors that people were using about any, and we humans tend to anthropomorphize everything. We use anthropomorphic metaphors all the time unconsciously. But it struck me that these metaphors that we actually were using had a lot of influence on ourselves and others about what these systems were and how to think about them. So, I have been thinking about this for a while, and it's come up even more lately, as we sort of battle over how to think about what these large language models are. Are they like humans? Are they like populations of humans? Are they like aliens, intelligences? Are they stochastic parrots, as one paper described them? Are they, autocomplete on steroids? Are they, there's all kinds of ways that people have characterized them. And it really does influence how we think about them. And one of the points I made in that science piece is that, like, this actually can be really important in the real world. One of the main arguments that people have made in these copyright infringement cases against AI companies that the companies make is that it's just like, an AI being trained on a copyrighted book is and then generating stuff in the style of that author. It's just like a human reading a book and thinking about it and then being able to talk about the book or generate things in the style of that book or having it influence us. So that's a metaphor that people don't even realize it's a metaphor because they actually think it's an identity. But it's something that might be very convincing to a judge or a jury, and so can have like really important real world effects of how we think about these systems. Are they more like intelligent humans, or are they more like a database or a library? And I really like some of the work of people like Alison Gopnik from UC Berkeley, who has written about these systems as not saying that they're not intelligent agents. We shouldn't think about them that way. We should think of them more as what she called cultural technologies, akin to, say, a library or the internet, that are technological artifacts that organize human knowledge and help us access it in novel ways. And writing, the invention of writing is another example of this. And so I think that's a very useful metaphor to think about these systems. And yeah, I could go on and on about this topic, but that's probably enough.
Wonderful. Thank you so much.
Thanks for your question.
Melanie, I'm sad to say that we are out of time. I know been chatting with our behind the scenes folks, there's audience questions that we just can't get to today, I'm afraid, but I guess that means we'll just have to have you back for an event like this or bring you to campus or something, because I'm so grateful for the time and I feel like I've learned so much. We want to make sure that in addition to thanking you for your generosity this afternoon, to thank our Dean, Jeffrey Cohen, our Dean of Humanities, and our English Department Chair, Nish Powell, for their support, and to Victoria Day, Bruce Matsunaga, and Alyssa Arms for their help organizing this event. We also want to thank Michael Finan at Macmillan for helping make these events possible. And finally, we want to thank all of our incredible teachers at ASU whose day-to-day work with our students makes for a brighter future. So grateful for your time this afternoon, and we'll look forward to future conversations.
Great. Thanks for having me. It's been a lot of fun.
All right, we'll see you.
Bye-bye.